Let us review what and all we have seen so far. Then last week we have seen introduction to sensors and transducer. In that we have seen what is electric current. Electric current is flow of electrons. We have seen every material in the world is made up of atom, that we know. But in some material at room temperature, the electrons will be move away from its defined orbit. It goes away from the defined orbit. Those electrons are called free electrons. If you apply a potential difference across two ends of that material, there will be a flow of electrons. That is called electric current. How to understand the potential difference? Potential difference is identical to pressure difference across a pipeline, water pipeline. For that, we can see, we saw this example. This is an overhead tank. In that, this is similar to our home. This is in the upstairs. Inside our house, we have the tap. If you open the tap, there is a flow of water because there is a pressure difference across two ends of this pipe. Because of that pressure difference, there is a flow rate through the pipe. This flow rate can be varied by adjusting this valve opening, the tap opening, valve opening. Why there is a difference in flow rate? Because of resistance. Because of resistance. Each material has identical to electrical, this is the resistance, identical to electrical resistance. If we close this valve, resistance to flow increases, that's why water flow rate decreases. In the same way, some material has a resistance to flow of current. That's why less electric current. If you consider the same situation here, this battery develops a pressure difference of 5 volt, potential difference of 5 volt across this 5 ohm resistance. That's why there is a flow of electrons, that is V by R, that is 5 by 5 equal to 1 ampere. The current through this resistance, this 5 ohm is identical to this tap. This 5 volt is identical to keeping the tank overhead in the upstairs. That's why there is a pressure difference, that is 5 volt. Because of that, there is a flow rate. This example may be very difficult to find the analogy between electric current and water flow. If you consider this example, it will be more convenient. This pump develops a pressure difference across two ends. This end and this end and this end. This end is A, let us call. This end is B. Between A and B, it develops a pressure difference. This pump, centrifugal pump, develops a pressure difference across A and B. That's why there is a flow rate. Let us assume that initially this pipe is filled with water. This pump develops a pressure difference across A and B. Here, negative pressure, here positive pressure. Positive pressure. That's why there is a flow rate. If you put a tap here, if you adjust this tap opening, there will be a change in flow rate because of resistance. This is identical to electric circuit. This pump is identical to a battery of 5 volt. This tap is identical to this resistance 1 ohm. Therefore, there is a flow of current is 5 volt divided by 1 ohm equal to 5 ampere. 5 volt divided by 1 ampere equal to 5 volt divided by 1 ohm equal to 5 ampere. So this 5 volt is identical to pressure. 1 ohm is identical to resistance like a tap. That's why a current of 5 ampere you can see. That example we have seen. Then we have seen the difference between DC current and AC current. DC current means, in this case, we have seen DC current, 5 ampere DC current. AC current means it varies continuously like this, sinusoidally it varies. If you plot between time and magnitude, it varies like this. Goes to maximum, then comes to minimum, then again goes to maximum. This part is going in the opposite direction. Electron is flowing in the opposite direction. Then flows in the positive direction, negative direction. Like that it flows. There's such a type of flowing of electron is called AC. Our power supply is AC, not DC. If you take power supply from battery, that is DC. If you take power supply from EB, electrical board, then it is AC. We used to use AC only. Its voltage is 220 volt. 50 hertz power supply we are getting at home. In college also we are getting 50 hertz. 50 hertz is the standard in India, UK and all. In the United States, it is 60 hertz. It means this going up and down, this is one complete cycle. From A to B is one complete cycle. Like that, in 1 second, it will vary 50 times. It will vary 50 times. But its maximum value will be 276 volts and minus 276 volts in the negative direction. It is called 220 volt RMS. Root means square value. Because here we cannot call in terms of maximum voltage or minimum voltage minus 376. Instead, it is equivalent to this 220 volt is equivalent to DC equivalent. DC equivalent. Suppose I am having one resistor. This is a resistor. This is a resistor. I kept this resistor in a water bath. If you flow current through a resistor, the water bath will get heated. That is called immersion heater. You might have known. If you put immersion heater and if you apply 220 volt DC, in 1 minute, let us assume that its temperature increased from 30 degrees centigrade to 100 degrees centigrade. Let us assume in 1 minute, it increased from 30 degrees centigrade to 100 degrees centigrade for a given quantity of water. Suppose I am having the same amount of water, same initial temperature, and I am immersing another coil, but here I am giving 220 volt AC. Here also in 1 minute, the same amount of heat is given. That's why its temperature raised from 30 degree to 100 degree centigrade. Means this 220 volt DC is equal to 220 volt AC. But its maximum value is different. But it is varying. That's why how to call it. That is called DC equivalent. RMS value. Root means square value. We'll square that value, integrate for 1 cycle, and find the root of that value. That is equal to 220. That is physically equivalent to 220 volt DC. 220 volt DC. So DC equivalent value is 220. So we call it as 220 volt AC, 50 hertz. Why they are using AC instead of DC means some advantages are there. Transmission becomes simple. That we have seen another example. Because in NLC, one alternator means one generator. We call it as alternator. 400 megawatts. 400 means 400 into 10 power 6 watts. This is about 40 watts. 400 megawatts generator that produce power. If you want to transfer that much power to this Pondicherry means you need a conductor of size, because it is identical to water. I said, no, current is identical to water. That's why the conductor size must be of room size. That is not possible physically. That's why they will raise the voltage, because watts equal to VI cos phi. Let us assume that cos phi is constant of 0.8. Then if you increase V, I automatically will decrease. That's why they will transfer 25,000 volt. They will transfer at the rate at very high voltage. Therefore, current is reduced. That's why wire thickness becomes very thin. Otherwise, cost of copper, you think. Cost of copper transmitting. Another problem is the power drop. Power loss will be proportional to current, not voltage. Power loss will be there if current is more. So these are the advantages using AC. That's why they are transmitting through AC. Then it is stepped down to 11 kilovolt, 11,000 volt. Then at your street corner, they will put one transformer that will transfer 11 kilovolt to 440 volt 3-phase or 220 volt single phase. So that is applied to home. You understand this? So how it works? It is by principle of transformer. Transformer means A coil, if you put a coil like this, two coils are there. If you wind the wire like this, then it is called coil. If you give here, I am having 500 turns like this inductor, 500 turns here, N equal to 500. I am applying 220 volt here. Here also 500 turns. Number of turns equal to 500. Same thickness wire. Here 220 means here also 220 volt. Another transformer I am having 250 turns. How much? 250. But here I am having 500. Then if I apply 220 volt, here I will get 110 volt. So if you reduce the number of turns, then the voltage will be reduced. Voltage will be reduced. Like that, they will step down the voltage and use, it will be converted into usable voltage. Usable voltage 220. The same principle is applied. How the power is transferred without any connection, without any physical connection, how the power is, electrical power is transferred here? Because here it produces magnetic flux. This primary coil, this is called primary coil, this is called secondary coil. This primary coil produces flux, magnetic flux. That magnetic flux will be going like this. This magnetic flux will going like this. That also links with this secondary coil. Because of that, there is an induced EMF. Whenever there is a change in flux, there will be induced EMF. There will be induced voltage. Whenever there is a voltage, there will be a current. So the power in this primary is transferred to secondary through flux, magnetic flux, through magnetic flux. So that action is called transformer action. That is called transformer action. Here we are using air as a core. Are you able to follow what I am saying? It means the flux is going through air. The flux is going through air.